Okay, so what we had just covered, right? All these different components, JButton, JText area. Oh, we didn't really cover JText area. I'll mention that. A JText area is basically a multi-line text box, right? So a regular text box just has one line where you can add text. JText area just allows multiple lines, and it has the same basic methods as a JText field. You can do set text to fill it with a certain text. You can do get text to fill it with to read what's in it. You can do set editable to allow the user to edit what's in the text box or not. And last, there's an append method. Append method will add text to whatever's already there. So, and if you really want, you can also add J-scroll bars to, allow scrolling up and down in a large text box. Otherwise, what's there is it's going to display as much text as it can given the room that's available. So it's kind of a funny thing. All the text will be there, but it won't all necessarily be visible. All right, and if you're interested in how to do that, as always, Stack Overflow is your friend. There's a link if you want to try that out at some point for some reason. Okay, but you don't really need to know how to do that for the exam. Okay, JButtons, of course, we've seen JButtons in our coding example. Basically, JButtons are clickable objects, and the programmer can specify actions for them, right? So what we did in our code, if we wanted a JButton to do something, number one, we have for JButtons, it uses the interface action listener. So an interface is kind of like inheritance, except you only get to use methods of another class. So it's a similar thing. We can bring in another class that by design in Java says other classes can show up and use these methods in the same way. So action listener works behind the scenes that when you click a button, it says action listener says, oh, you have, well, basically here's what happens. Good that I can draw this in Paint. So suppose you have a JButton that you want to do something by some object, and we'll call that object OBJ. Okay? So in the class header, you note that OBJ's class implements the action listener interface. And we'll have a more example, again, okay, by that magic word, implements interface. Then you include the action performed method, parentheses, from action listener in the OBJ's class's definition, right? Now, different interfaces will have different methods, but action listener is an easy one because it only has one method, action performed, right? We're not picking that up. Okay, excuse me. And then third thing, we register the the listener for the JButton, right? In this case, as the object OBJ. So that means whenever the button gets pressed, whenever the button gets clicked, OBJ is going to do that. Now, what happens behind the scenes, excuse me, we have some JButton. Wherever it is, I got to capitalize the B. We have a JButton that when it gets clicked on, because we've implemented this interface behind the scenes, okay, so click, goes to the action listener interface. And the action listener interface says, check the listener. All right, so it says, who's the listener? Well, for this particular JButton, it's OBJ. So call obj.actionPerformed. Okay, we call that method, and then, we're there. The action happens. Okay, so all this stuff, this happens behind the scenes, right? What we see as a user, we see this part happens, and we see this part happens. Obviously, it gets from point A to point C somewhere there, right? But this stuff, this all happens behind the scenes. Oh, I wanted to actually have that be green. And we're going to fill you in. Ah. Oh, because it needs to be green. There we go. Okay, this happens behind the scenes. Hidden from the user, hidden from the programmer, hidden from us. Excuse me. Okay, so this is essentially the map of what's going on. We just do these things. We say, okay, there's a button. I know the button is going to use action listener because that's kind of built into the JButton class. And when I register it with action listener, I say OBJ is the object that's going to respond. Then the action listener interface knows, oh, I call that method for OBJ when somebody clicks on a button, right? And that's how we get from somebody clicking on a button. There's nothing in this code directly that says, if someone clicks on a button, do this. All we have this button that exists and has add action listener this so that the current kframe object will respond. And then the kframe class has this action performed method, right? The other details, they're hidden behind the scenes from us. We don't really need to know about them. We just know it works. Does that make sense? I hope. Questions? Would you like to know more? Okay. You all know you get Tuesday off, right? Because the election, you didn't see, I didn't know either this morning. Yeah. In general, students are totally on top of days off. Right. So, yeah. But it was news to me. I hadn't really checked. And, you know, I had to, even after a student told me, I was like, well, that sounds right, but I got to check it out. You know, I got to actually go check it out before I, you know, just decide to not come in for work one day. So, yeah, but it turns out to be correct. Okay. Now, colors. Java by default uses these standard 24-bit RGB colors, R for red, G for green, B for blue, and they're provided in the java.awt.color class. So when you import that whole package, java.awt.star, you get them all. And colors can be accessed in a bunch of different ways. Number one, there are quite a few static color constants built in, like color.red, color.black. There's more than you'd think, really. So if I did this, for example, I'm going to set a color for JB. This.jb. Set background. Okay, and I can just do color dot, and look at all the ones I get. I get black, I get blue, I get cyan, light blue, dark gray, regular gray, green, light gray, magenta, super fancy, orange, pink, red, right, and yellow. Strangely, no orange. Why no orange? I don't know. There was? Oh. Strangely, no purple. No purple. These things have changed over time, too. So there have been some that have, you know, been there and disappeared. These basic ones, these are like your basic 16 that you get, you know, kind of like these, except you don't get purple. You don't get some of these. You don't get this like sand color either. Anyway, but yeah, there, you know, there's a few. And for the rest, of course, for the rest, you can create them by our three numbers, which you've seen me done. So these three numbers, the RGB codes, they're luminance values. Okay, so basic 5th grade physics quiz. What happens when you blend together all the colors of visible light? Brown? No, white. Yeah, white. You're like, don't you remember 5th grade? You like do the stuff with the prism and you bring the regular light in and it breaks up into the rainbow, and then the rainbow catches the Skittles and turns back into all white. Skittles? Taste the rainbow? You skipped 5th grade? Went straight from 4th to 6th? Yeah, okay. Anyway, but yeah, right? So if you blend all the light colors together, if you max them out at 255, you get white. Now what's the color of the absence of light? Black, right? Like a black hole, light doesn't escape. So If you put all those at zero luminance for any of them, basically you're turning out all the lights on that pixel, right? And that means it'll be black. And somewhere in the middle, right? What's halfway between white and black? Medium gray, right? There's light gray, there's dark gray, but there's medium gray. Medium gray like 128, 128, 128. Dark gray, 64, 64, 64. Light gray, 192, 192, 192. If you're old school, you know all these numbers of 64 because it was a lot faster to know them than to do them with a calculator. Anyway, so there's that. And you can send those as 3 separate numbers, or you can combine them all into one 24-bit int. So you add the blue just as the bottom 8 numbers in the binary number. You multiply it by 256 for the green, so you get the next 8 bits. And then you multiply red by 256 twice, or 65,536, to get the next highest batch of 8 bits, right? Most people who are not robot-like find it much easier to work with the 3 numbers separately. I'm just saying there's an option there to do it. And there may be some applications where it saves it all as one. This, the bottom line is, of course, much more efficient in terms of memory consumption, right? So if you're sending 3 separate numbers, those are 3 ints. That requires 12 bytes. That one at the bottom is still an int. It only requires 4 bytes. So if you're dealing with large images, it's much more efficient to compact them all into one number. Just saying, that's why it exists. Okay, so what should you know about colors? Obviously, no one expects you to memorize every possible shade of color that could be produced. Certainly, you should know that it's composed of 3 numbers between 0 and 255 that each represent the different luminances of red, green, and blue, right? There you go. Okay. Now again, stacking GUI components, by default, it looks like stacking on pictures onto the J-frame, right? It's just stack them on top, and whatever's the last component added, unless you have some transparency effects built in, the last component added in any space blocks everything underneath it, right? So, for example, like we did, if you add additional J panels, you're going to block whatever's underneath them, and we did a demo with that. So, to display multiple components on the same GUI object, we often use layout managers. The reason is, JPanel in particular will blow up to fill up all the available space, right? A JButton, under most circumstances, will only fill up, you know, the size of what's necessary to hold its text, right? But a panel is going to expand and fill up everything. So what's the problem with that? Well, if you have one panel, if you want to add on multiple panels to draw in multiple ways or do some slightly more advanced graphic stuff, you have to use a layout manager to divide the base panel into regions, right? And that's what we've done here in the code that we had. You may vaguely recall, I can get rid of that line, I don't really need it. We had this JP base, right? JP base was the first thing that we added, if I can find where I added it, just plain JP, right? JP, I added it to the frame, I gave it a background color, but it's not visible. And I set its layout as a grid layout. So grid layout is one of your basic layout managers. In this case, it divides it into 2 rows and 2 columns. Okay, so let's see what grid layout says. Yeah, so if you hover over some of these things, you can find out some information, right? So grid layout is the number of rows, number of columns. This is going to be a 2x2 thing. So basically, there are going to be 4 regions, 4 cells on that panel, and each of those cells, I can add something to it. I could add a panel to it that'll fill up the whole cell. Weird thing, if I add a button onto a cell, even though if I add a button to a J panel, it'll just be a tiny thing on the panel. If I add it to a grid layout cell, it'll swell up to fill the whole thing, which usually looks ridiculous. Okay, so there's that. I could do this. I could do a 2x3. Thank you. You all done? Yeah. That was quick. All right.
What was I gonna say?
I don't know.
Speaking of that 201 class you're talking about.
Yeah.
I know I sucked at Java.
Yeah.
But your class actually, I hated coding.
Oh.
I took a Swift developing class, and I got a job offer from Chamberlain Groups after I finished that class.
Yes.
So I'm going to school part-time, and I took a full-time job starting next week.
Awesome. Congrats.
Thank you. Appreciate it.
See, this is good stuff. After Java's rough, but after Java, everything else is going to be easy. Who's paying him? Yeah, all right.
Thank you.
Welcome. It's just been a day of testimonials, hasn't it? Okay. Anyway, so you saw what I did. I added on a new cell to this. And if I add on to this.jp add new J button and add on, I'm going to call it big, right? It'll have the text there. You're going to see it's going to look ridiculous. Boom, there it is, this huge, ridiculous J button filling up the cell. And then behind it, this is, remember, the base panel is red, so we only have 5 things filling up this 3x2. So this one, there's nothing covering it. So we're just seeing the base J panel under there. But this is a whole big, ridiculous button. Okay, looks kind of stupid, doesn't it? I mean, that's my point of view. I don't know. Maybe there's an application where it's appropriate. Okay. Excuse me. Wow. Okay, so 3 different layout managers we're going to cover: box layout, flow layout, and grid layout, right? There's a bunch of other ones. There's like a dozen or so. That's part of the standard language. Other people can make their own, layout managers. But these 3, those are the basic ones. Now, you can also do absolute positioning by pixels, right? You can say, start drawing this thing at, place this J button at pixel 100, 200. You can do that. But the problem with doing that is if somebody resizes the frame, it's going to look all messed up. So again, it is permitted. Java will let you do it. Like if you're writing something for your own machine that nobody else is ever going to use, yeah, fine, go for it. Use absolute pixels. But in the real world, nobody would do that. Okay, so we'll talk about the 3 ones, but we'll start with flow layout first. Flow layout is simple. So, easy way to remember flow layout, it looks like centered text on MS Word. Okay? If you start typing on MS Word and the text is centered, where's the first word going to appear? In the middle, right? There you go. What if you add on a few more words? That's right. It's going to expand equally on both sides, right? Because it's centered. What if you add in so much text that it spills over to a line? Where is that new text on the next line going to appear? In the middle, because it's centered, right? That's how flow layout works. You add components. If you add, it'll try to center them horizontally on the top line. If you add so many components that it gets too wide, or you shrink the frame width enough that stuff spills over to the next line, they'll still be centered, but on, additional lines. Okay? That's flow layout. Easy, right? MS Word, centered text, same thing. So if you understand MS Word, you understand this. Next one is the grid layout. So again, grid layout, we basically say how many rows you want, how many columns you want, right? And it divides that space into equally sized cells. So one quirk though about the grid layout, if you don't need all the columns you ask for, they won't ever get added. For example, if in my layout here, right, I have 5 things. If I say I want 5 rows and say 256 columns, see what happens. Still just get 5 rows. It says, hey, you only have 5 things. I can display those in the first column. I don't need those other 255 columns, right? So that's one quirk about grid layout. You can ask for more columns, but it's only going to use the ones that you actually need. Excuse me. Second, components are fitted to the grid elements, right? So for panels, that's usually great, right? Panels swell up to fill everything anyway. You wouldn't want it any other way. That's what J panels are for. J buttons or some other components like J text fields in particular can look ridiculous, right? So you have this one little tiny line of text, but the box itself is huge. Looks silly. Anyway, so yeah, that's grid layout, and there's a couple quirks there. Last one, box layout. So box layout essentially allows you to add components in a line either horizontally or vertically, right? So it says allows flexible orientation of components within a container object. And the syntax for this one is really weird because the constructor call for a box layout actually has to specify the container and an orientation. And in general, you're calling a box layout on the component itself, right? So for example, you do JP is a new JPanel. You call the set layout method to add a layout manager to it, to apply a layout manager. And then we call the box layout constructor, new box layout. And to that, we send JP itself as an argument. You say, okay, box layout, you're going to apply this box layout to JP, which is kind of weird, but whatever. And then you specify if you want either a y-axis or an x-axis orientation. So y-axis displays from top to bottom, x-axis left to right for you guys. Okay, that's what the box layout is. So you should know, the general rules of those three. But again, there are many, many others. Some are interesting. Java, GUI, layout managers. Okay, so anyway, border layout, box layout, card layout, flow layout, grid bag, grid, group layout, spring layout. And those are just the ones that are already included in this stuff. So you can check out some of these if you want to look at them. But, for what we're doing, the basic three are totally fine. But there's more. And that's just the ones that Oracle has as part of the official Java. So, okay. Now, listener interfaces, right? So the main point of GUIs is that they respond to user actions, right? It's a user interface. Somebody clicks on something and something happens, right? So things like clicking buttons you want to happen. And again, Java uses a special set of classes called interfaces for this. Interfaces, again, it's not like inheritance where you get all the data fields and all the methods from the parent class. An interface class basically says, I'm going to let you use some of my methods, right? So the interface class action listener has an action performed method, and when you implement the interface, your button clicks, like I drew in that picture, right? They go through the interface and go to the appropriate destination method. So the three things you got to do: number one, implement the interface class with the class that is actually going to respond to the GUI actions. Number two, include any interface methods, right? And we'll see there's more. And then finally, associate the listener with a particular object, right? So for the J button, we did add action listener. It's the same for a J text field. I'll do an example with some mouse ones too. Anyway, once those steps are done, Java's going to handle all the jumps behind the scenes for the execution flow, right? So those interface methods, they're called as needed. So if somebody clicks on a button, that's when it happens, right? And if it's not needed, then nothing needs to happen. And when it's done with action performed, right, it's not part of the main flow of the application sequence. Again, if you just look at the code for this, you see here in the main method, right, all I've done is created a K-frame. And just by the basic rules of Java that we learned like week 3, that should be the end of things, right? We made it to the end of the main method, the application is done. But with GUIs, it's different. We implement some of this stuff. There's kind of this perpetual multi-thread thing going on where it's always listening for actions to happen. And so, there's like one thread for the frame itself and potentially another thread for other things going on. That's why you have to specify this exit on close, because otherwise the application won't stop just because the window goes away. All right, so it's a little different structure there. Okay. Anyway, so the net effect of all this is there's a separate execution thread for every event. Every time somebody clicks on a GUI button or expands or shrinks the screen, the window, that's going to generate a new action thread where something else is happening. Okay. So yeah, here we go through the great black box of mystery, right? Fortunately, we don't need to know how any of that stuff works. And the reason why it's hidden is because the details of how it happens are going to be machine specific, right? If this were C++, it'd be a little bit different. We'd be focusing on specific chunks of memory and saying how this happens. But Java's like, yeah, you know what? You don't need to know all that. That doesn't matter. We'll take care of that for you, right? So all we need to know, somebody clicks the button, things go through this mysterious interface process, come out the other end at the action performed method. Ta-da. Okay. Now, when you have a GUI, it's got to continually listen for user actions like entering text, clicking buttons, whatever. When any events happen that are being monitored, right, the execution flow has to jump to that particular method. And this is done through interfaces. Programmers affiliate them with components or containers. In our example, we affiliated the button with the K-frame. We also affiliated the JText fields with the K-frame, right? So whenever any events happen with those, the K-frame object is going to be the one that responds. So one thing, advanced stuff, I'm not going to ask you about it on the exam or anything, but if you do try to do something a little bit more complicated with these GUIs, and there's a lot of events that can happen at the same time, sometimes the execution order can be a bit unpredictable. If this were an advanced course, I'd teach multi-threading. I used to do that. When I taught 401, I teach multi-threading. And when I have honors college students, sometimes I throw that in as a separate thing they can learn about. But now I don't. Anyway, but you can have some event calls, method calls blocking others or taking priority over others. Things don't always work the way you think they would. Even with multi-threading, things don't always work the way you think you could unless you take a lot of care to force it. One of the things I do in multi-threading is I set 3 simultaneous timers, and I set them all to, count down 100 milliseconds at a time, do tenths of seconds. And very quickly, they start to get a little bit out of line with each other, just, because of weird stuff behind the scenes and priorities. Some of those computations get skipped over. All right, so basic interfaces, window listener, all this stuff handles things like opening, closing windows, activating, deactivating windows, stuff like that. What's that? Too much?
Yeah, I'll just have a long way, so.
Okay. All right. All right, so let's do this. I'm going to do a new example with mouse stuff. All right, so we're going to do mouse tracker. We'll see what we get with that. All right, so once again, we're going to import our basic classes, java.awt.star and java.awt.event.star, and we are going to import javax.swing.star, right? Again, the 3 packages that'll let us do GUI stuff. So mouse tracker is going to, I'm thinking what it's going to do. It is going to extend JFrame. So that's an easy one. We're going to do all our basic JFrame stuff here in the constructor. All right, so give it a size. We'll skip the thises. Set size, we'll make this 1200 by 900. And this one, we're going to set the title. The title will be nothing to start with. The action closed, right? Set default close operation. Exit on close. And then finally, set visible true, right? These are the 4 things that usually, setting the size is usually a good idea. Setting the default close operation is a good idea. Setting visible is good. Setting title is pretty optional. So, but we'll do it because you'll see it why in a moment. So, for this one, for mouse tracker MT is a new mouse tracker object. Okay, and we're just going to have this thing run. Now, let's give it a JPanel. Call it JP, and we're just going to add JP to this thing. So JP is a new JPanel, and add JP. Okay. Okay, so when I move the mouse over, now I'm going to do this thing. So there's 2 mouse classes, but I'm going to do implement mouse listener. So mouse listener has some different methods. I'm going to bring those in. Click there. I'm going to add the unimplemented methods. Remember, we have to include these methods so if that kind of event happens, the interface has somewhere to send the execution flow, right? Otherwise, it won't. Otherwise, it'd be like, hey, I'm supposed to do something mouse click, mouse entered, whatever, but there's no method here. So we're going to do mouse entered. Oh, no, I need mouse motion listener as well. I'll do both of them. There's some overlap between the two. Okay, same thing. I'm going to implement these ones as well. Okay, so for entered, I'm going to change the background color to red when the mouse crosses it, and I'm going to change it back to gray when it leaves. Okay, light gray. So jp.set background color.red. Okay, and for this one, when somebody leaves, color.light gray. And I'm going to set that as an option here as well. And then, yeah, jp.add mouse motion listener this. jp.add mouse listener this. So the first one, the mouse listener, is going to respond when I cross that boundary. All right, so I'm in there. Oh, what happened? How am I doing this? Okay, so all it sees, if it crossed the boundary into the J panel, lights up. Easy, right? Ta-da. Now, do a similar one. I can add on a couple things. Let's say if I am moving around within it, where is my mouse moved, right? Anytime I want to read the mouse coordinates, you get this mouse event. Remember, the mouse event contains some details about the event that actually triggered this method call. And one of the things for a mouse event, you get the X and Y coordinates of where it happened. Okay, so if the mouse is moving within it, I can do string S, or I can do int X equals me dot get X, right, which is an int. And I can do int Y equals me dot get Y. So I'm just reading the X and Y coordinates, right? So I'll say here, read X and Y coordinates of the mouse location, cursor location. And then I can print it out as the title. I can do set title that plus X plus Y plus final parenthesis. Okay, so I'm just going to do that coordinate pair inside parentheses, and I have to do the separate mouse motion listener for JP. Okay. And once again, I register it with this particular mouse tracker frame object as the thing that's going to respond. See, so you'll notice in the upper left, it's actually showing the pixel coordinates. Okay, so I can try to see if I can hit 0, 0. There we go. Ta-da! And all the way down to 1200, 900 or thereabouts. Kind of neat, huh? Almost feels like we're doing something real. That's what happens with these frames, right? It's like, hey, I can make colors happen. I can actually do something. And if you want to design a shitty video game, you could totally do that. Yeah. Anyway, once in a while I'll do some fun things for my kid. You know, I may have showed you Slugfall, which was sort of like a retro game that, you know, it might have been commercial grade 40 years ago. And I also made like a math practice thing with, you know, multiplication options for him that like generates random questions and he's got to type in the answer. So, and in the past I've done like question and answer applications. So you can enter in like lists of questions and answers if you want to make a flashcard app. People have done stuff like that too. Just saying. So now you'd be able to do any of these things. Okay. So yeah, there's, you know, mouse listener, mouse motion listener, there's action listener. Again, there's a bunch of other listener classes out there in the world. You don't really need to know what they are, but they exist. Java listener interface classes. All right, let's see what they have here. Let's see how many he includes. Action listener, adjustment component, container, focus, item listener, key listener, mouse and Yeah, there's a bunch, right? And again, those are just the ones that are built into the language. So if you ever wanted to learn more, here's where you might go. Okay. So these are just code examples for the stuff we've already done. Again, using interfaces, you specify some method that happens when an event happens. So you got to do a couple things, 3 things. Implement the listener class with the class whose objects are going to listen. So if you want a K-frame object to respond, to actually run that action perform method, you have to do the implements action listener in the class header. Then you have to add the object itself as a listener for a particular component. So if you want a JButton JB to generate an event that's actually responded to by that K-frame, then you would add the K-frame object, assuming that's in the K-frame class, and so it's this. You would say jb.addActionListener this, and then that K-frame object would be the thing that runs action performed when somebody clicks JB. And then add all the interface methods to the listening class. So you, in the K-frame class, you add that action performed method, so the execution flow has a place to go, right? The interface is going to say, oh, somebody clicked this J button. I'm supposed to have the K-frame class, K-frame object, execute action performed. If there's no action performed method there in K-frame, something very bad is going to happen, right? Your program's going to collapse. So that's, in effect, it's like a checked exception. Okay, last things, we're getting into it. The rest is just some coding examples. It often happens that a GUI has multiple elements of the same type. If they have multiple elements of the same type, they can generate the same event, right? So if you have multiple J buttons, they could all generate action events. If you have multiple text boxes, they could all generate action events, right? And again, that's fine if they have the same outcome, which is unusual. But yeah, maybe they do. Maybe you have 4 buttons on the sides of the window that you all want them to do the same thing. Much more likely it's something like a calculator app, where you have like 40 buttons on there and every button does something a little bit different. Okay. So the event parameter, thing to remember, the event parameter, so action event in an action event method call contains that source data, right? Everything about the action event, primarily the object that was clicked to generate the event in the first place. And you can find the source of the event by calling the event object's getSource method. So we had that right here in K-frame, right? So down here in action performed, we have this, right? We read which particular object is the source of the event. So if the event source was JB, so our action event is called E here. We say E.getSource is JB, then it's going to change that one background to purple, right? Remember, we pressed that button, it made it purple. Otherwise, they'll say, yeah, maybe the event's getSource is JTF1. And if it does that, it takes the text from that text box and assigns it to the frame title, right? So that's how it distinguishes, because both this and this, right, both generate action events, but you need to know which action event source was the one that actually happened to make the proper thing happen. Okay. So, simple example for a button click, you have some class K-frame, you include the magic words implements action listener in the class header, you add the K-frame object as the action listener for the J button, so that if someone clicks on the J button, it knows that that K-frame object is the thing that needs to respond. And then you put that method in the K-frame class itself, right? So here we have action performed, action event E. You don't have to put anything in particular in the body of the method, right? Here I just print out thanks because the button says press me, and that'll work, right? So when you press the button, it'll print out that message to the console that says thanks. Similar, if you're reading text from a J field, right? J text field rather, also uses action listener because a J text field really only does one kind of, action. So implements action listener goes in the class header. You register the K-frame object this as the thing that responds to an action event from the text field. And then again, you include that action performed method in the K-frame class itself, right? So in this particular one, it says print you entered such and such. So it reads the text using, the event source's get text method. So we know that e.getSource in that case would be a JText field, so there's no problem with calling a get text method on it. In fact, buttons can also have text. They just returns the text that's printed on it. Okay. Likewise, if you have multiple event sources, right, you have 2 J buttons, one that says press me, one that says don't press me, go through the usual process, right? We implement action listener in the class header. We have assigned we assign the K-frame object this to both JB1 and JB2 as the action listener. And then down in the action perform method, that orange text, we check e.getSource. So if the source of the method call, or if the action event source was JB1, it prints out thanks because that one said press me. But JB2 said don't press me. So if the event source is JB2, it says stop that. Ta-da. Okay. So I feel like I've covered the stuff. I'm going to dig through my old history. I'm going to find an old one. This is the one that I brought up on the first, I don't know, maybe the first week of classes. I have an old Connect 4 app that maybe I included it last semester. I can't remember anymore when I do things. But I have brought it in prior courses. I designed it a few years ago. I'm going to see here in my demo code if I have it. Connect 4, Connect 4, Connect 4. There we go, Connect 4. I also have a little tic-tac-toe app if, whatever. That's pretty trivial. You do that. Let's lift that code. I'll put that up in Eclipse. We can play a little tic-tac-toe. Tic-tac-toe. Okay. So this one, if you want to check this out, right, and look at how, some of this stuff works, like I said, this is way beyond what you would need to do for purposes of this course. All right, but here we have some names. It'll be me against Fred, I guess, and we're going to start playing. All right. X. All right, I'm going to block you, Fred. Is Fred good? Well, he's not that good. Let's see. Aha, you can't beat me. Oh, and Fred misses. He clicks the wrong thing. The clicking doesn't always work 100%. I think it's a combination of the surface here is not great for it. But then, and now the game's over. And if I wanted to, I could play another one. So let's see. Yeah. All right, and this one I'm just done. I think I thought there used to be a button down here that, yeah, I can't remember. It's been a while. But this particular computer, the screen is not very big. The other one I have, Connect 4, we're going to have some of that same problem trying to run it on this machine, though. But, I mean, it's valid. It's just not going to work great here. All right, so this one, Connect 4, again, which unfortunately is not great for this particular machine. I'll just put in that code there, and I can run it. We have a little Connect 4 app, right? So I can start off, oh, I think with this one too, there's something similar going on. I have to, there we go, I can start. Boom. Okay. Aha, red goes first. Now yellow, now red, now yellow, now, why is this a problem? There we go. Oh, and they missed it. Player 1. Exciting. So much drama. All right, rematch? Sure. No. Okay. Anyway, you can do fun stuff like that if you want, but I just did that, a little bit of more advanced stuff, and there's some custom graphics built in there. We'll cover that a little bit next week in the graphics lecture. So I don't know. You tell me, is there anything here? I mean, I get it at this point. You're not going to have everything memorized, and that's fine. So let's discuss briefly what you should know for the exam, right? That's a topic that is certainly near to everyone's concerns. So, what from all this should you know for the exam, right? Well, number one, basic properties of GUIs, right? So all those things that we discussed, you know, how things stack, you know, resizing, stuff like that, the tree of components, those are the sort of things you should know, okay? Number two, the different component types, right? Basically, be able to recognize and describe them. You know, for example, if I give you a list of 5 options, 4 of them might be real components and the 5th one be, you know, something else. You got to recognize which one isn't real. Things like that. Okay. What else? Different layout manager types. Okay. Be able to recognize and describe them, right? Because there could be a question like, hey, which of these describes how the flow layout works? Or which of these describes how the grid layout works? Stuff like that, okay? So that, I think, oh, and colors, right? The format for colors, right? Basically, constants, 3 RGB numbers separately, or 1 combined value. Okay, know how to create new colors, how to assign them, all that. And methods for this, I guess, you know, basic event handling, right? So for example, a coding question might ask, you have to write the method code for action performed to cause a, I don't know, I'm just thinking out loud here. You have to write the method code for to cause, I have to give a little bit more context, right? So suppose you have a JPanel named JP on a JFrame object, okay, which implements the action listener interface. Okay, so I would have to like give you all that stuff. You have to write the method code for action performed to cause the JPanel to change color, for example, right? Something simple like that might come off this. Or likewise, or a J button is placed on a JPanel JP, right? Write the code, a JPanel named JB is placed on JPanel. Write the code to make JP change color to green, with the caveat that there are many J buttons that could generate the event, right? So basically, hint, use get source, right? So something like that. And again, you wouldn't have to memorize this whole structure. I would give you a reasonably, you know, appropriate amount of it, but what I would ask is like, do you understand how get source works? Do you understand how some of the, thank you, how some of these other things work as far as changing background colors of components, stuff like that? Okay. And again, it's great if you know the methods exactly, but if your stuff is structurally correct, and instead of writing set background, you write set background color, which is an easy mistake to make. It's like, yeah, you might get dinged a tiny bit for that, but that's not a major mistake. At this point, I'd be focused mostly on, do you understand the structure of how things are supposed to work? It's a lot to, you know, remember the exact method. So, okay. So that's where we're sitting with all this. I don't know. Are there any questions or concerns or anywhere where you would like more detail? Or the amount of detail has already been more than sufficient? Yeah. Okay.
Are we still gonna be able to have like a full class period to go over the last exam?
Yeah, yeah, eventually we will, I'll have them all graded, certainly by Thursday, and we'll go over them on Thursday. Yeah. Okay. That's my plan at this point, because before then I wasn't sure, I didn't know that Tuesday was off, but now that Tuesday is off, yeah, we really got to go over it on Thursday, because when else is it going to happen? Otherwise it gets to be too long. Yep. Okay. Well, that's all I got then. It's a bit of a short thing, but then today's kind of like Friday, so. All right. I'll upload all these to Blackboard. I think K-Frame might already be up there, but these other ones I can upload. All right. Enjoy the break. Anybody out here in virtual land? Yeah, a couple. Oh, look at that. Some people out here. How about that? All right, great. All right, we'll see you next time. It's been a hoot.